Sorry.
Yeah, hi all. Good morning. So can you please confirm my voice is audible or not?
Yes, sir.
Okay. And I hope my screen also visible.
Yes.
Okay, thank you. So as part of yesterday's session, we started discussing about our data warehousing concepts. So as part of data warehousing concepts, we discussed about what is data, what is information, what is the data warehouse, and we discussed about what is the data warehousing architecture. Then we discussed about what is ODS, and we discussed about what is OLTP and what is OLAP, and we discussed about what is the difference between OLTP and OLAP. So these are the different topics we covered as part of our yesterday's session. Now today we'll continue with other topics. So if you remember, as part of our yesterday's session, we discussed about the data warehousing architecture. What is the data warehousing architecture? So we are going to have the ODS. On top of ODS, we are going to build the staging database. On top of staging database, we are going to build the data warehouse system. On top of data warehouse system, we need to create the views. On top of the views, report development team will create the reports. On top of that, our end users are going to perform the analysis. This end-to-end flow, we are calling it as nothing but data warehousing architecture. This is the one. So we are having the ODS. On top of ODS, we build the staging. On top of staging, we are building the data warehouse. Then we are going to create the views. On top of that, report development team will create the reports. By using the reports, our end users are going to perform different types of their analysis. This whole flow we can able to call it as nothing but data warehousing architecture. Okay. Now here we need to understand in the today's session what all are different types of data warehousing architectures we are having. So we are having two types, which we can able to call it as centralized data warehousing architecture, and second type we can able to call it as nothing but federated data warehousing architecture. So we are having two types of architectures. One we can able to call it as a centralized data warehousing architecture. Second one we can able to call it as nothing but federated data warehousing architecture. Now, actually, in both architectures, we are going to see all the components, ODS component, staging, data warehouse, views, reports, everything is going to common in between both the architectures. We'll try to understand what is the difference in between the centralized and federated. With that, you can able to get the clear picture, what is the centralized data warehousing architecture and what is our federated data warehousing architecture. If you see here. So if you see, so this is our generic data warehousing architecture. As per the previous diagram, we are going to see the ODS and we are going to see the staging and data warehouse and views and reports. This is the kind of a detailed diagram of our data warehousing architecture as we discussed in the yesterday's session. We are going to see the ODS, staging, data warehouse, views and reports. On top of the reports, our end users are going to perform the analysis. This is our detailed architecture of our data warehouse. Now, if I want to simplify this diagram, what we can do here, if you observe here, we can able to simplify the diagram like this only. By using the multiple sources, we are going to build the data warehouse system. On top of this data warehouse system, our end users are going to perform the analysis. Indirectly, we are converting this detailed diagram into the simplified diagram. As part of simplified diagram, we are saying that by using the different types of the sources, we are going to build data warehouse system. On top of data warehouse system, our end users are going to perform the analysis. Now, this is the simplified version of our detailed architecture. In the detailed architecture, we are discussing about ODS, staging, views, reports, everything we are discussing in the detailed architecture. But for this detailed architecture, this version we can able to call it as nothing but simplified version. In the simplified version, we can able to see different types of the sources. On top of that, we are building our data warehouse. On top of that, our end users are going to perform the analysis. Now, if you see this simplified diagram, what is the centralized component we are having? It's nothing but our data warehouse. For that reason, this kind of architecture simply we can able to call it as nothing but centralized data warehousing architecture. Indirectly, yesterday, whatever the architecture we discussed, Randy, whatever this whole architecture we discussed, this architecture only we can able to call it as nothing but centralized data warehousing architecture, because as part of this whole architecture, what is the centralized component, which is nothing but our data warehouse. That's the reason whatever the yesterday detailed architecture we discussed, that whole architecture indirectly we can able to call it as nothing but centralized data warehousing architecture. Only for your visual purpose, I converted this detailed diagram into the simplified diagram. In this simplified diagram, if you observe here, what is the centralized component we are having? It's nothing but our data warehouse. That's the reason this kind of architecture we are calling it as nothing but centralized data warehousing architecture. Any questions up to here? Please ask me. Now, only this is for the visual purpose, and don't assume that. So, in between the source and data warehouse, we are not going to maintain the staging database. Don't think like that. Definitely, we are going to have all the sources. Now, you tell me where this source 1, source 2, and source 3 are going to be available. Where this source 1, source 2, and source 3 are going to be available. All these sources are going to be available in the ODS. Only for the visual representation, instead of ODS, I'm calling it as a source 1, source 2, and source 3. Now, on top of all these sources, what is the next step? Obviously, we have to build the staging database. On top of that, we have to build the data warehouse. On top of that, we need to create the views. On top of that, we need to create the reports. On top of that, our end users are coming into the picture for the purpose of doing the analysis. But instead of putting each and every component, just I'm given the high level diagram. By seeing the high level diagram, you can able to understand what is the centralized component here is nothing but our data warehouse. For that reason, this detailed architecture or this high level diagram, simply we can able to call it as nothing but centralized data warehousing architecture. Okay. Any questions up to here? Please ask me. Okay. No questions I can able to say. Whatever architecture we discussed in yesterday's session, the type of architecture we can call it as centralized data warehousing architecture. Yesterday we haven't given any naming convention, but just today I'm saying that whatever the yesterday's end-to-end architecture we discussed, that whole architecture we can able to call it as nothing but centralized data warehousing architecture. Now we need to understand what is the federated data warehousing architecture. It's very simple. As part of federated data warehousing architecture, we will introduce a new layer in our data warehousing architecture. So as part of federated data warehousing architecture, what we are doing here, just we are introducing a new layer on top of our previous architecture. We are going to introduce a new layer. That layer only we are calling it as nothing but data marts. Whatever the new layer we are introducing as part of our federated data warehousing architecture, that new layer is nothing but we can able to call it as a data marts. Immediately you will get the question, sir, what is data mart? So we can able to say data mart is nothing but subset of our data warehouse system. So what we can able to say, data mart is nothing but this is the subset of our data warehouse system. Yesterday, if you remember, we discussed that in the data warehouse system, we are integrating data from different sources, or we can able to say we are integrating data from different departments. In the yesterday's Citibank example, we are having the savings department, we are having loans department, we are having demat department, and we are having the current department. From all the departments, we are going to collect the data. With that, we are building our data warehouse system. Indirectly, we are integrating the data from different types of the sources. On top of that, we are building our data warehouse system. Now, what we'll do here is, as part of data marts, we will segregate data for individual departments into individual databases. As part of data marts, what we are going to do here is, instead of maintaining all the data in the single data warehouse system, we are going to create the individual data marts. In every individual data mart, we are going to maintain the data for individual departments into our individual databases, and that kind of layer only simply we can able to call it as nothing but data marts, or we can able to call it as nothing but this is the subset of our data warehouse system. Indirectly, now our architecture will become like this. Obviously, we are going to have the ODS. On top of ODS, we are going to build the staging database. On top of that, we are going to build the data warehouse system. On top of that, we are going to create the views, reports, and end users. This is our normal architecture. Now, in this architecture, what we'll do here is, just we are introducing a new layer. That layer only we are calling it as nothing but data marts. After building the data warehouse system, we are going to build the data marts here. So this is the new layer we are introducing on top of our data warehouse system. In the data warehouse system, what is happening here? We are having data for all the departments, or we can able to call it as integrating the data from different types of departments into our data warehouse system. After that, again, we are going to segregate the data for individual departments data into our data marts, and indirectly in each and every data mart, we are going to see data for individual departments. Except that entire remaining architecture is same only. Here just we are introducing a new layer. On top of data warehouse, we are going to create the data marts. In the data marts, we are going to maintain data for individual departments data or individual database data. On top of that, we need to create the views and reports. Then our end users are going to perform the analysis. Whenever we are going to maintain the data marts, that kind of architecture we can able to call it as nothing but federated data warehousing architecture. If you observe, in between centralized and federated data warehousing architecture, everything is common. Only thing is nothing but we are introducing one extra layer which we can able to call it as nothing but data mart. For that reason, we are saying that data mart is nothing but it is the subset of our data warehouse system, or we can able to call in the data mart, we are going to maintain data for individual departments into our individual databases. Just I will show it in the Excel sheet, then you can get a clear picture. Just we'll see one real-time example. For example, if you are going to work in the insurance sector, any cases in the insurance sector, what kind of departments we can able to see? In the yesterday we discussed about the banking sector. In the same way, today we'll try to understand about the insurance sector. In the insurance sector, what kind of departments we can able to see? Any idea?
Yeah.
We can able to see one department called as nothing but policy department, or we can able to call it as nothing but policy subject area. In the same way, we can able to see one more department called as a claims department, which we can able to call it as nothing but claims subject area. And we can able to see one more department called as a ASA, which we can able to call it as nothing but agency subject area. So like this, in the insurance sector, we can able to see the different types of the departments. Whenever you want to take the policy, we need to reach out to the policy department. Whenever you want to apply for the claims, we need to reach out to the claims department. Whenever you want to reach any third party people, then we need to reach out to the agency department. So like that, in the insurance sector, we can able to see PSA, which is nothing but policy department, CSA, which is nothing but claims department, ASA, which is nothing but agency department. Now, what all these departments will do here? All these departments will handle different kind of transactions. All these departments are going to handle different kind of transactions. After that, they will store all the transactions. For example, they are storing it in text file. They are storing it in JSON files. And these people are storing, for example, in the XML files. Okay. Now you tell me where these text files and JSON files and XML files are going to store as part of our data warehousing architecture.
ODS.
Obviously, our ODS. Perfect
Source.
answer. Now, source is nothing but indirectly in this insurance sector. Yesterday we discussed about Citibank example. Just today we are discussing about one more domain, insurance sector. In the insurance sector also we can able to see the multiple departments. All the departments are going to perform different kind of transactions. They are storing all these transactions into either text file or JSON file or XML file. All these files are storing in our ODS system. On top of that, we are going to build our staging database. On top of that, we are going to build our data warehouse system indirectly. Now, in the data warehouse system, we are going to have data for CSA, and we are having data for PSA, and we are having data for ASA. Then we are going to create the views. On top of that, we are going to create reports. On top of that, we are going to create end users are going to perform the analysis. Now, you tell me, if I am going to give the inflow like this, what kind of architecture it is? In this architecture, are we calling anything data marts here? We are not introducing any data mart here. For that reason, this kind of architecture simply we can able to call it as nothing but centralized data warehousing architecture. Now, for example, if I am going to take the same diagram one more time, one more flow. Now here, after the data warehouse, here what I will do is, I will create CSA data mart. I will create PSA data mart. Then I will create ASA data mart. So what I'm doing here indirectly, just I'm introducing one new layer. In this new layer, we are introducing different data marts only. And as I told you, in every data mart, we are going to maintain the individual department data. Now in this flow, how many data marts we are going to create? Data mart 1, data mart 2, and data mart 3. Indirectly, we are going to maintain the 3 different data marts. In the first data mart, we are going to maintain data for claims data. Second data mart, we are going to maintain data for policy data. In the third data mart, we are going to maintain the agency data. So like that, we are going to split in the data for individual departments into your individual data marts only. Because of introducing this layer, what we can able to call here, this kind of architecture we can able to call it as nothing but federated data warehousing architecture. In the both the architectures, everything is common. Only thing is nothing but here we are introducing a new layer. That new layer only we are calling it as nothing but our data mart. That's the reason we are saying here data mart is nothing but subset of our data warehouse. What is the meaning of subset? If you see in this data mart, whatever the CSA data we are having, the data is present in the data warehouse. Whatever the PSA data mart we are having, the data is available in the data warehouse. Whatever the ASA data or agency data we are having, that data also present in the data warehouse. For that reason, every data mart is nothing but indirectly is a kind of a subset of your data warehouse system. That's the reason we given the definition is nothing but data mart is nothing but subset of our data warehouse system. Okay, this is the way by using one real-time example we can able to understand centralized data warehousing architecture. At the same time, we can able to understand about our federated data warehousing architecture. Now, if you see this Excel sheet, now what type of architecture it is? Just try to give the answer. We are having different sources. On top of that, we are building our data warehouse system. As per our example, in this data warehouse system, if you are considering the insurance sector, here we are having the PSA data, agency data, and claims data. On top of that, what we are introducing here, just we are introducing a new layer called as a data mart. In data mart 1, we are having policy department data. Data mart 2, our agency department data. Data mart 3, claims department data. On top of these data marts, our end users are going to perform the individual department analysis by depending on their requirement. So whenever we are having this kind of data mart layer, that kind of architecture only we can able to call it as a federated data warehousing architecture. Now you tell me, this we are calling it as a federated data warehousing architecture, but this is the high level diagram or this is the detailed diagram? Any guesses? This is the high level diagram or this is the detailed diagram of the federated data warehousing architecture?
High level diagram.
This is the kind of the high level diagram only for our easy understanding. But if you are converting this high level diagram into the detailed diagram, then we can able to see the architecture like this. And if you see now, again, we are having ODS, staging, data warehouse. On top of data warehouse, we are going to build the multiple data marts. On top of that, again, we are going to create the views and reports. On top of the reports, our end users are going to perform the analysis. This whole architecture is completely same in compared to our centralized data warehousing architecture. Only extra difference here is we are introducing a new layer called as a data mart. That's the reason just we are calling it as a federated data warehousing architecture. Okay. Any questions up to here? Please ask me.
So what is the use of this data marts? Because already we have the data in data warehousing system.
Yeah, actually, if you're having data in the data warehouse, here what is happening? We are having data for all the departments together. But here my client requirement is in the client team, we are having the different end users. One end user want to perform analysis for only policy data. One other user want to perform analysis for only agency data. One other user want to perform analysis for only claims data. Now, individual users are going to perform analysis for individual departments data. Then you tell me, better to maintain the data in data warehouse system. If you are going to maintain data in the data marts, what will happen? It is very easy to access to the end user. For that reason, we are introducing the new layer called as nothing but data marts. But you tell me, in every project, are we going to see the data marts? Obviously, no. By depending on the client requirement or by depending on the business people requirement, either we are going to maintain the data marts or we are not going to maintain the data marts only. If we are going to maintain the data mart, then we can able to call it as a federated. If we are not maintaining the data marts in our project, that we can able to call it as a centralized data warehousing architecture. But coming back to your question, what is the purpose of data marts here? If end user want to perform analysis on the individual departments data by depending on their requirement, then we are maintaining the data marts. If we are going to maintain data marts, that architecture we can able to call it as a federated data warehousing architecture.
Okay, sir. So yeah, that means we can assume like we can assume these data marts as separate databases, sir.
Yes, correct. See, staging database or data warehouse or data marts and views, where we can able to see all these things. Staging database, data warehouse component, and data marts component and views, where we can able to see all these things. All these things we can able to see in the database only. Only in the ODS we are having data in the files format that we can able to see in the drive, or that we can able to see in the Unix server, or that we can able to see in the SharePoint location. But whatever the remaining components we are discussing, all these remaining components are present in your database only. Staging database is present in data warehouse. Data warehouse also present in the database only, and data marts also present in the database only. Views also will present in the database only. But coming to data marts, here what we can able to say, for every department I will create the individual database in my database system. For example, if you are working on the Teradata, or if you are going to work on the MySQL, in the MySQL what we can do, we can able to create the individual databases, right? For every department I will create the individual database. PSA one database, ASA one database, CSA one database. Like that I will segregate the data into the individual databases. But from the data warehousing terminology, instead of calling it as individual databases, we are calling it as nothing but data marts.
Okay.
Is it clear? Okay.
Yeah.
Any other questions?
Yeah, I have one question, sir.
Yeah, please.
In the data warehouse, again, why we are keeping it's a part of the data part or a subset, like so that instead of maintaining a duplicate data here, again loading from staging to data warehouse and data warehouse to data mart, instead of staging DB to data mart is good idea, right?
Yeah, directly you can able to load the data like that also. In some of the projects we'll do that activity. Your question is completely valid, because in this architecture what is going to happen, in the data warehouse we are going to maintain the PSA data. At the same time in the data marts also we are going to maintain the PSA data, which is nothing but indirectly we are going to maintain that duplicate data. Now for example, as part of your project requirement, you don't want to maintain this kind of duplicate data, then what we can do here, simply we can able to remove the data warehouse layer. Directly we can able to build the data marts by depending on our requirement. That's a perfectly valid question. And in some of the projects we are going to see directly data marts without having any data warehouse system.
Okay, sorry. Thank you.
Okay, only for understanding, just I'm showing you the end-to-end architecture. Now, for example, if I'm not going to display the data warehouse here, what will happen? People can able to get the confusion. That's the reason, as part of end-to-end architecture, I'm showing you the data warehouse and data marts only. But coming to your question, in some of the projects, what will happen, by depending on their requirement, without building data warehouse system, directly they are going to build the data marts as part of the project requirements. In that situation, what will happen? No need to maintain any kind of duplicate data in data warehouse and data marts. Okay.
Sir, also the staging tab always it is like truncate and load, right, sir?
Yeah, obviously it's a kind of a truncate and reload, because here on top of what we are going to perform the analysis, on top of data warehouse and on top of data marts, we are going to perform the analysis. Now, why we are using the staging database? For the purpose of doing analysis or to convert one format of data into other format, we are using the staging database. to convert one
convert.
format of data into other format. Only for that reason we are using the staging database, but where we are going to perform all our analysis and we are performing all our analysis on top of our data warehouse or on top of our data marts. For that reason, in data warehouse or in the data mart, we are going to see the current data plus historical data, but in the staging database, always we are going to see the only current data. That we can able to call it as nothing but indirectly is a kind of a truncate and reload. Every day we are going to truncate the data in the staging database, then we are going to reload the data. That data only we are using loading on top of our data warehouse system. But in the data warehouse system or in the data marts, what we are doing here is not a kind of a truncate and reload. Every day we are going to perform the appending operations on top of your existing data.
Okay, sir. Thank you.
Okay. Now see here, whatever the diagram we discussed here, and in this diagram, if you observe here, data marts are depending on the data warehouse system indirectly. First, we need to build the data warehouse. On top of data warehouse, we need to build the data marts. If you are going to follow this kind of approach, such kind of data marts, we can able to call it as nothing but dependent data marts. Actually, here we can able to understand like this. We are having two types of data marts. First, we can able to call it as a dependent data marts. And second type of data marts, we can able to call it as nothing but independent data marts. So dependent data marts is nothing but if you are building data marts with the help of data warehouse system, such kind of data marts we can call it as dependent data marts. So whenever we are going to build the data marts with the help of the data warehouse system, such kind of data marts simply we can able to call it as nothing but our dependent data marts only. Now in the same way, what about the independent data marts? We can able to say if you are going to build the data marts without depending on data warehouse system, such kind of data marts we can able to call it as nothing but independent data marts. Indirectly, here we are having the two types of data marts. One we can able to call it as a dependent, other one we can able to call it as a independent. If you are going to build the data marts with the help of the data warehouse system, such kind of data marts we can able to call it as a dependent data marts. If you are going to build the data marts without depending on the data warehouse system, such kind of data marts we can able to call it as nothing but our independent data marts. And now you try to give the answer in this flow or in this architecture, whatever the data marts we are discussing, what types of data marts it is? In this flow, whatever the data marts we are discussing, all these data marts are depending on top of your data marts here, data warehouse here. For that reason, in this example, these data marts we can able to call it as nothing but dependent data marts. And whatever the approach we are following here, that approach we can able to call it as a top-down approach. And it's very simple. Top-down approach is nothing but first we are building the data warehouse. On top of data warehouse, we are going to build the data marts. Whenever we are following such kind of architecture, we are calling it as a federated data warehousing architecture, or this architecture or this approach we can able to call it as a top-down approach only. And we have a person called as a Kimball. Actually, we can able to say we are having two authors of our data warehouse system, or we can able to say these are fathers of data warehouse. Who invented data warehouse or who are the authors of data warehouse system? We are having two people. First person name we can able to call it as a Kimball. Second person name we can able to call it as a Inman only. So first person name is nothing but Kimball. Second person name is nothing but Inman. Coming to Kimball, he suggested the approach called as a top-down approach. For that reason, same approach we can able to call it as nothing but Kimball approach. Whatever the federated data warehouse architecture flow we are discussing here, in this flow we are discussing about the dependent data marts. Whenever we are going to follow the dependent data marts, that kind of approach we can able to call it as a top-down approach, or we can able to call it as nothing but Kimball approach only. So why we are discussing all these terminologies here is nothing but if you are going to work in the real-time projects, in requirement document, they will mention that in this project we are following Kimball approach. So for example, this is the one-line statement you are seeing in the requirement document. Now by seeing this statement in the requirement document, indirectly what we need to think? We need to think that, okay, in this project, they are following the Kimball approach, which is nothing but they are following the top-down approach, which is nothing but here we are going to follow here we are going to maintain the dependent data marts. So with that, we need to understand, first we need to build the data warehouse system, then we need to build the data marts, and that's the reason they are calling it as a Kimball approach. And now, for example, in our class, if we are not discussing all these kind of terminologies, if you are going to work in the real time, what will happen? In the requirement document, you are seeing it as a Kimball approach, but you don't know what is the meaning of Kimball approach. Then you went to your team lead or you went to your manager and you are asking the question, sir, can you tell me what is the Kimball approach? If you are going to ask these kind of questions to the team lead or manager, with that simply they can understand you are a kind of a fake employee. And if for that reason, if you are going to work as a data engineer, compulsory we need to understand all these kind of terminologies. For that reason, we are discussing all these terminologies as part of our class. Okay, now actually whatever the flow we discussed here, this flow we can able to call it as a federated data warehousing architecture. In this flow, whatever the data marts we are using, these data marts are depending on the data warehouse. For the reason, these data marts we can able to call it as nothing but dependent data marts only. And this approach we can able to call it as a top-down approach. Who suggested this approach? Kimball suggested this approach. So this is the way you need to understand different naming terminologies which we are going to use as part of our federated data warehousing architecture. Okay. Now in the same way, for example, now you tell me here, what is the difference between the previous federated architecture and this architecture? This flow and this flow, what is the difference now? In this flow, what I'm doing, first we are building the data marts. On top of the data marts, if you want, we can able to build our data warehouse system indirectly. In this architecture, whether data marts are depending on the data warehouse or data marts are the independent of the data warehouse here. As part of this flow, we can able to say your data marts are not depending on the data warehouse system. That's the reason, if you are following this kind of approach in your project only, then we can able to call it as nothing but here we are using the independent data marts, or we can able to call it as nothing but we are following bottom-up approach. So here we can able to say, if we are going to build the data marts first as part of your project, then we can able to call this approach is nothing but our bottom-up approach, or we can able to call in this project we are going to maintain the independent data marts only, and this approach is suggested by Inman. That's the reason this approach, if you want, we can able to call it as a Inman approach also. For example, in the requirement document, whenever we are going to see the statement, in this project we are following the Inman approach. By seeing the statement, what we need to understand? We need to understand in this project, we need to build the independent data marts, which is nothing but we are not building data warehouse system first. We are building the data marts. That kind of approach or that kind of architecture only we can able to call it as a Inman approach, or we can able to call it as a bottom-up approach only. But if you observe here, either in this flow or in this flow or in this flow, in all these flows, what is the common thing we are having? ODS is common, staging is common, data warehouse is common, views is common, reports is common, end users is common, everything is common. Don't get any kind of confusion, Sandy. Everything is common between all the three different types of the approaches. Only thing is nothing but in the federated data warehousing architecture, just we are introducing a new layer, which we can able to call it as a data mart. Data mart is nothing but this is the subset of our data warehouse system where we are going to maintain the individual department data. Now, for example, if you are building the data marts on top of your data warehouse system, that we can able to call it as a dependent data marts. That approach we can able to call it as a top-down approach, or we can able to call it as a Kimball approach. For example, if you are building the data marts without depending on the data warehouse system, that kind of data marts we can able to call it as a independent data marts, and that approach we can able to call it as a bottom-up approach, or we can able to call it as a Inman approach. And all these are the just different naming conventions which we are going to use in our real-time projects. For that reason, just I'm trying to put all these naming conventions as part of our discussion. Okay. Now, just I will ask few questions. You try to give the answers here. For example, in the requirement document, you are seeing one information like this. In this project, we are going to maintain dependent data marts. Now you tell me indirectly, in this project, what approach we are following? In the requirement document, you are seeing that in this project, we need to maintain the dependent data marts. This is the kind of statement you are seeing on top of your requirement document. Indirectly, what type of architecture we are following in this project?
Top-down approach.
It's a
Top-down approach.
I'm asking
Fed-
about the type of architecture,
federated.
not asking the type of approach. It's nothing but
Federated.
Federated.
federated data warehousing
Warehouse.
architecture. Now, indirectly, what type of approach we are following in this project?
Kimball.
What approach? We can
Kimball
able to call it
Kimball
as a
approach.
top-down
Top-down.
approach, or we can able to call it as nothing but Kimball approach. Okay, in the requirement document, they will say that in this project, we are going to maintain the dependent data mass. Then simply we can understand that, okay, here we are going to follow the federated data warehousing architecture, or we can able to think that here we are going to maintain the top-down approach, or we can able to think, okay, here we are going to maintain the Kimball approach. Okay. Now, for example, in the requirement document, they are giving the one more statement like this. In this project, no need to maintain any data mass. Now, indirectly, what type of architecture we are following here?
Centralized architecture.
Nothing but our centralized data warehousing architecture. Now you tell me, in the centralized data warehousing architecture, do we have any concept called as a top-down approach and bottom-up approach? In the
No.
centralized, we don't have any such kind of concepts, and only in the federated we are having the concept called as a top-down approach, or we are having the one more concept called as a bottom-up approach. Now, for example, in the requirement document, you are seeing the statement like this. In this project, we are going to follow the in-one approach. Now, indirectly, what kind of architecture we are following here?
Federated.
We are following
Data warehouse
the federated data warehousing architecture. And here, how we are going to build the data
Bottom-up
mass?
approach.
First, we need to build the data marts. On top of data marts, we need to build the data warehouse. And this kind of approach only we can able to call it as nothing but bottom-up approach also. So this is the way, by seeing the requirement document, you should be in the position to understand what kind of architecture we are following in the project. For the reason, just we are discussing about all these statements from the last 20 to 30 minutes only. Still, if you are having any questions on top of all these things, please ask me. And one more sincere request, don't get any kind of confusion. Here, everything is common between all these kind of diagrams or all these kind of architectures only. Only thing is nothing but, as part of federated data warehousing architecture, just we are introducing a new layer called as nothing but data mart. By depending on the position of the data mart, either we can able to call it as a top-down approach, or we can able to call it as a bottom-up approach. Except the data marts, all remaining things are common in between your centralized data warehousing architecture and federated data warehousing architecture. I am giving all these statements not to confuse you, and to understand in the real time we are going to see different kind of naming terminologies. To understand all those naming terminologies, you need to have all this kind of knowledge. For that reason, we are discussing about all these kind of statements. Okay. Any questions up to here, please ask me. If no questions, I will ask one question, try to give the answer. In real-time projects, who will decide what kind of architecture we need to follow? Any guesses? If we are going to work in the real-time projects, who is going to decide what kind of architectures we need to follow? I am giving the answer, data engineer. Is the correct answer?
No.
This is simply
No.
wrong answer, Andy. So as a data engineer, you are not going to take any kind of decisions at the architecture level. Here we can able to say our data modelers. So we are going to have the data modelers, or we are going to have the data architects, Andy. Either data modelers or data architects will decide. By depending on the client requirements, they will decide whether we need to go for the centralized data warehousing architecture, or we need to go for the federated. Within the federated, whether we need to go for the top down or we need to go for the bottom up. All these kind of decisions will be taken care by your data modelers and data architects. Then why we are discussing? Because in the real time, you need to understand the requirement document. In the requirement document, you are going to see all these kind of terminologies. For that reason, we are trying to understand what is the centralized data warehousing architecture, what is the federated data warehousing architecture. But if you are going to work in the real-time projects, your data modelers or your data architects will decide what kind of architecture we need to follow as part of our real-time projects. Okay. Now, here we can able to say, as a data engineer, you need to have some minimal knowledge on data modeling concepts. See, here we are not doing any kind of data modeling activities, Andy. But if you are going to work as a data engineer in the real-time projects, you need to have some minimal knowledge on the data modeling concepts. So why we need to have the minimal knowledge, which we are going to cover in next 5-10 minutes, Andy. But just I'm giving the statement like this: in the real-time projects, as a data modeler, they will decide what kind of architecture we need to follow. They will decide what kind of modeling activities they need to perform. But as a data engineer, you need to have some minimal knowledge about our data modeling concepts, because in requirement documents, they will specify something like this. In this project, will follow star schema, or they will specify in this project will follow snowflake schema. And in the requirement document, they are going to specify this table is the fact table, and they're going to specify this is the dimensional table. Okay, actually here indirectly all these terminologies, either fact table or dimensional table, star schema, snowflake schema, all these are the different terminologies which are comes under the modeling. And now as a data modeler or as a data architect, in the requirement document they are saying that this table is the fact table. For example, they are saying that they are giving one table as a result underscore summary table, and they are saying that this table is nothing but the fact table. Now, can you able to understand what is the meaning of fact table? If you don't know about what is the meaning of fact table, obviously you cannot able to understand what is the meaning of the fact table. Without understanding the meaning of the fact table, you cannot able to understand what is the purpose of the result summary table. Without understanding this purpose of this table, you cannot able to create the pipeline properly. For that reason, to understand the requirement document in the proper way, you should have some minimal knowledge on top of our data modeling concepts. And for that reason, we are going to discuss about some basic concepts on top of our data modeling. Again, I'm repeating the same statement. As a data engineer, in the real time, you are not going to perform the data modeling activity. But as a data engineer, you need to have minimal knowledge on the data modeling concepts, because to understand requirement documents in real-time projects. To understand the requirement documents or to understand the requirements in the project, you should have some minimal knowledge on the data modeling concepts. For that reason, as part of our class, we are going to discuss about some basic modeling concepts, and with that, easily you can able to understand the requirements as part of our real-time projects. Okay. Now, actually here, on top of data modeling, we are having two types of data modeling we can able to call. One is nothing but ER modeling, and second type of modeling we can able to call it as nothing but dimensional modeling. So in the data modeling side, we are having the two types of modeling techniques. And one we can able to call it as a ER modeling. Second type of modeling we can able to call it as nothing but dimensional modeling. Any guesses what is the meaning of E and what is the meaning of R here?
Entity relationship.
We can able to call it as a entity relationship model. ER model is nothing but entity relationship model. So in this model, what will happen is, in this kind of model, we are going to maintain a relationship between each and every table. So as part of ER modeling, what will happen is, we are going to maintain the relationship between each and every table. Now, for example, I'm having table 1, table 2, table 3, table 4, and table 5. So what will happen is, table 1 can able to have relationship with T2, T3, T4, T5, and table 2 can able to have relationship with T3, T4, T5, and in the same way, for example, T3 table is going to have relationship with T1, T2, T4, and T5. Like this, if you observe here, each and every table, what is going to happen? Each and every table is going to have relationship with all other tables. And whenever we are going to maintain the relationship between multiple tables like this, such kind of model, simply we can able to call it as a ER modeling. But problem with the ER modeling is here is nothing but to retrieve the data from all these tables. To retrieve data from all these tables, we need to apply so many number of joins. Tell me here why we need to apply the so many number of joins? Because every table is having interrelationship with the multiple tables, and T1 is going to have relationship with the remaining 4 tables, T2 is going to have relationship with the remaining tables, and T3 is having relationship with the other tables. Like that, every table is having relationship with the other tables as part of our ER modeling. For that reason, as part of retrieving the data here, what we need to do here, we need to apply the so many number of joins on top of your SQL statement. Now you try to give the answer. Whenever we are going to increase the number of joins in the SQL query, your query performance will increase or decrease? query performance
Decrease.
obviously will degrade. Okay, so that's the reason, as part of ER modeling, if you want to retrieve the data, we need to apply the more number of joins, and which is going to cause the query performance degradation. That's the reason, as part of data warehousing projects, we are not going to use ER modeling to avoid more joins on huge amount of data. Now you tell me here, in the data warehousing projects, we are going to deal with a huge amount of data, or we are going to deal with a less amount of data? As we discussed yesterday, in the data warehousing projects, we are going to deal with the current data plus historical data, which is nothing but, in data warehousing projects, we are going to deal with a very huge amount of data. And in this data warehousing projects, if we are going to apply the ER modeling, what we need to do here, you need to apply the so many number of joins, and because of applying the so many number of joins, your performance is going to degrade. And if you are going to apply so many number of joins on top of huge amount of data, obviously what will happen, your performance of the system will be very degraded. For that reason, as part of data warehousing projects, we are not going to use the ER modeling. And why we are not using the ER modeling? Because to avoid the more number of joins on top of huge amount of data, we are not going to use the ER modeling. Then what type of modeling we are using in the data warehousing projects? So we can able to say, in data warehousing projects, we are going to use dimensional modeling. So in the data warehousing projects, what we are going to do here, we are going to use the type of the modeling called as nothing but dimensional modeling. Just for understanding, I explained about what is the ER modeling, but in the data warehousing projects, what type of modeling we are going to use? We are going to use the dimensional modeling. Dimensional modeling is nothing but, as part of dimensional modeling, we are having centralized table, which is having relationship with all surrounded tables. Just try to understand the statement, Andy. So as part of dimensional modeling, what will happen here is, we are going to have the centralized table, which is having relationship with our all the surrounded tables indirectly. Whatever the centralized table we are having, that table we can able to call it as a main table, or we can able to call it as a fact table. Yeah, for a few minutes we'll forget about the fact table. So whatever the centralized table we are having, that table we can able to call it as a main table. All the surrounded tables indirectly we can able to call it as nothing but child tables. Now what is going to happen? We are not going to maintain the relationship between each and every table, and you are having the one centralized table, which is nothing but our main table, which is surrounded by the multiple child tables. With the help of one main table, we are going to maintain the relationship with our all the surrounded tables. Just I will show you the diagrams. With that, you can able to get the clear picture. If you observe, yeah. So this is the dimensional modeling. In the dimensional modeling, what is going to happen? You can able to see the one centralized table, which is surrounded by the multiple child tables. And now this centralized table is having relationship with the surrounded table, other surrounded table, which is nothing but T1 is having relationship with only T2, T1 is having relationship with the T4, T1 is having relationship with the T3, T1 is having relationship with the T5, but we are not going to have any relationship between T2 to T3 or T2 to T4 or T4 to T5. Now, if we are going to create this kind of model, such kind of model, simply we can able to call it as a dimensional modeling. But in the ER modeling, if you observe here, what is happening? T1 having relationship with the T2 and T6 and T5 and T4. In the same way, T2 is going to have relationship with the T1, T3, T6 and T4. Like that, we are going to have the clumsy relationship as part of our ERE modeling. But in the dimensional modeling, just you are going to have maintain one centralized table, which is going to surrounded with the multiple child tables. With that, with the help of the main table or with the help of the center table, we are going to maintain the relationship with all the surrounded tables. And if you see this diagram, in between T2 and T4 or T4 to T5 or T5 to T3, we are not going to maintain any kind of relationship. If we are going to follow such kind of modeling, simply we can able to call it as nothing but dimensional modeling. Now I will ask one question, you try to give the answer. In which kind of modeling we can able to see the huge number of relationships? In which kind of modeling we are going to see huge relationships?
In ER modeling.
Obviously, we can able to say ER modeling. And in data warehousing projects, which kind of modeling we are going to follow?
Dimensional modeling.
Obviously, we can able to say dimensional modeling. Now, who is going to perform these data modeling activities in real time?
Data modeler,
Data engineer
modelers
or
are
data modeler?
architects.
We can able to say data modelers. Okay, try to understand the concept. Don't think about how we need to create all these things. Why Sir is discussing all these things. Don't think like that only. We need to understand the concept. We need to understand the terminologies. If you want to work as a 3 years of experience person in the real time, that's the reason we are trying to discuss. We are trying to understand what is the dimensional modeling. As part of dimensional modeling, we are going to have the central ledger table, which is surrounded by the multiple child tables. And in the central ledger table, we are calling it as a main table, and surrounded table we can able to call it as a child table. In between the child tables, we are not going to maintain the relationship. By using the main table, we are going to maintain the relationship with the child tables. That kind of modeling, simply we can able to call it as a dimensional modeling. Now, within the dimensional modeling, we need to understand what is fact and what is dimension. So within the dimensional modeling, we need to understand what is the fact, or we need to understand what is the dimension. Fact is nothing but it's a kind of a measurable value. So what is the meaning of fact? Fact is nothing but it's a kind of a measurable value. For example, in the yesterday's Citibank example we discussed, right? So as a business people, they want to perform analysis for each and every branch. And now you tell me, as part of doing analysis on top of each and every branch, what is the measurement they are going to consider? As per yesterday's example, in the yesterday's Citibank example, as a business people, they want to perform analysis on top of each and every branch. As part of doing analysis, what is the measurement they are going to consider to do the analysis? We can able to say turnover. In every branch, they need to get the turnover. On top of the turnover, based on the turnover, they are going to perform some kind of analysis. And now in the same way, for example, if you go to the retail domain, in the retail domain, based on which measurement we can able to perform analysis? Any guesses?
sales,
Profit, sales.
Obviously, we can able to say by using sales, or by using profit, or by using loss. And by using any one of these parameter, or by using any one of these measurements, we can able to perform the analysis. Now what I'm telling here, what is the meaning of fact? Fact is nothing but it's a kind of a measurable value. Now you tell me, in these two examples, what is the fact value we can able to say? Turnover is a fact, sales is a fact, profit is a fact, loss is a fact. Indirectly, whatever the measurable values we are having, all those measurable values, simply we can able to call it as nothing but facts. Okay. Now, for example, as a principal in the college, he want to analyze all the students and he want to decide who is the best student. Now you tell me, in this example, which measurement we are going to consider to decide who is the best student?
results,
Obviously marks, or we can able to call it as a results. Now this marks, indirectly what we can able to call in the dimensional modeling, this we can able to call it as a fact. Okay, whatever the measurements we are considering for the purpose of doing analysis, those measurements simply we can able to call it as a fact. Okay, now in the same way, coming to dimension is nothing but to define the fact values, we are going to use dimensions. To define the fact values, what we are doing here, we are going to use the dimensions, or we can able to call dimensions are nothing but descriptive data. So dimensions are nothing but to define the fact values or to define the measurable values, we are going to use the dimensions, or we can able to call dimensions are nothing but descriptive data. Now just I will give one example, try to understand this one. And for iPod product in Hyderabad location in 2020 year, sales is 1 crore. For example, this is the statement I am giving to you. For iPod product in Hyderabad location in 2020 year, what is the sales? Sales is nothing but 1 crore. Now you try to give the answer. In this example, what is the fact and what is the dimension? Just try to, I know you don't know about the fact and dimension at this moment, but try to give the answer as per our discussion. In this whole statement, what is the fact value? What is the dimensional value?
Fact values.
My partner sales.
Sales is nothing but fact, because this is the measurement we are considering for the purpose of doing analysis on the iPod product. On the iPod product, I want to perform the analysis. For that reason, I am considering the measurement value is nothing but sales, and this sales only we can able to call it as nothing but fact. Okay. Now in this example, what is the dimension?
iPod product, which location 2020
Our product name, location name,
location and year.
Year value. All these values indirectly we can able to call it as a dimension. Why? Because to define, if I'm given the only sales equal to 1 crore, you cannot even understand what is the meaning of the sales equal to 1 crore. And for that reason, to understand this fact value, or to understand this sales value, or to understand this measurable value, what I'm doing here, I'm giving some descriptive data for this product in this location, in this year. This is the sales, which is nothing but to define the fact value, I am using some kind of descriptive data. That descriptive data only we can able to call it as nothing but dimension. So for that reason, in this example, we can able to say sales is nothing but fact. And whatever the descriptive data we are using, or whatever the values we are using for the purpose of defining the fact value, that we can able to call it as a dimension. Any questions on top of fact and dimensions, please ask me here. Is it clear? Okay. Now, if it is clear, now you try to give the answer. Any guesses from your side? What is the meaning of fact table? Try to give the answer. If you understand about what is the meaning of fact, it is very easy to explain about what is the meaning of the fact table. What is the meaning of fact table? Simply we can able to say
a table which consists of only the numeric columns.
Yes, perfect. So in a table, if we are going to maintain all the fact values, such kind of table we can call it as fact tables. What is the employee table? If a table is having all the employees information, that table we are calling it as a employee table. What is the department table? If a table is going to contain all the department's information, then we can call it as a department table. In the same way, what is the policy table? If a table is going to contain all the policies information, that we can able to call it as a policy table. In the same way, what is the fact table? Fact table is nothing but if your table is going to contain all the fact values or all the measurable values only, that kind of table simply we can able to call it as a fact table. Okay. Now in the same way, try to give the answer. What is the meaning of dimensional tables or dimension tables? Same statement, just I'm going to copy paste. In a table, if we are going to maintain all dimensions or descriptive data. In a table, if you are going to maintain the dimensional values or if you are going to maintain the descriptive data, such kind of table simply we can able to call it as a dimensional tables only. Don't try to by heart anything here. Try to understand the concept. Once you understand the concept, it is very easy to derive the definitions only. So what is the fact here? Fact is nothing but it's a kind of a measurable value. Dimension is nothing but to describe the fact values, we are going to use the dimensions, and in whatever the table we are going to maintain all the fact values, such kind of tables we can able to call it as a fact table. In whatever the table we are going to maintain all the dimensional values, such kind of tables we can able to call it as a dimensional tables. Okay. Now going back to our dimensional modeling. In the dimensional modeling, what we are discussing as part of dimensional modeling, we are having the centralized fact table, which is having relationship with all the surrounded tables only. Now what I'm doing here is just I'm doing small modifications. We are having centralized fact table, which is having relationship with all the surrounded dimensional tables. Just I added the two words here in the dimensional modeling. We are having the centralized table, but the centralized table only simply we can able to call it as nothing but fact table. And this centralized table is surrounded with the multiple child tables only. Those child tables are surrounded tables. We can able to call it as nothing but dimensional tables. Now, what is the fact table? Fact tables are nothing but it is going to contain all the fact values. What is the dimensional table? It is going to contain all the dimensional values. Indirectly, in the fact table, we are going to contain the measurable values. In the dimensional table, we are going to have the descriptive values only. This is the way you need to understand what is the meaning of the dimensional modeling. In the dimensional modeling, we are using the terminologies called as a fact table and dimensional table. For that reason, we need to understand what is the fact and what is the dimension. Then we need to understand what is the fact table and what is the dimensional tables. Okay. Any questions again up to here? Please ask me.
So dimension table is nothing but our normal tables, sir.
No, in a normal table, if you are going to maintain the measurable values, that table we cannot able to call it as a dimensional table. And I will show you one example. For example, see, I am using one table called as a location table. Just to give one example. In this table, I'm going to maintain location ID. Then I'm going to maintain location name. Then I'm going to maintain city name. Then I'm going to maintain state name. Then I'm going to maintain country name. Now tell me, in this table, what data we are maintaining? We are maintaining descriptive data for each and every location. For every location, I'm going to maintain the location name. For that location, I'm going to maintain the city name. Then I'm going to maintain the state name. Then I'm going to maintain the country name. Indirectly, in this location table, what kind of data we are maintaining? We are maintaining our descriptive data. For that reason, this location table simply we can able to call it as nothing but our dimensional table. In whatever the table, we are going to maintain the descriptive data. Such kind of tables we can able to call it as a dimensional tables. Okay, now in the same way, for example, I am giving one more example for product tables. Now, for example, if I am having product ID, I am going to maintain product name. I am going to maintain sub product name. Then I am going to maintain category of the product. Now, indirectly in this table, what I am maintaining? I am maintaining data for each and every information of each and every product. What is the product ID? What type of product it is? What is the sub product? This is falling under which category of the product? Like that, we are maintaining all the details of each and every product in the product table. That's the reason this table also we can able to call it as a one more dimensional table. Indirectly, as part of these two examples, in the location table, we are maintaining all the details of the location. In the product tables, we are going to maintain all the details of the product. For that reason, these kind of tables simply we can able to call it as a dimensional tables. Is it clear?
So if you are adding the product table as a price, it will not come as a dimension table, sir?
Yes. No. If you are going to add the price, it will come as it will come under as a dimensional table. But if you are going to add the profit, or if you are going to add the loss, or if you are going to add the what is the total sales, if you are going to add these kind of values, or if you are going to add these kind of values only, then it is not calling as a dimensional table, because this is the kind of a summary data, or this is the kind of the measurable values. By using that, you are going to perform the analysis. For the reason, if you are going to maintain this kind of data on your product table, then we cannot able to call it as a dimensional table. So instead of calling it as a dimensional table, say we can able to call it as a normal table. Now you tell me, this table can be able to call it as a fact table? If we are going to maintain profit, loss, and total sales information, can we able to call this table as a fact table?
Yes.
Yes.
Again, answer is no only. So see here, in this fact table, other than fact values, what we are maintaining? We are maintaining the descriptive data also. But as per discussion, as per previous discussion, in the fact table, we are going to maintain only dimensions, or we are going to maintain only facts. We are going to maintain only the facts information on top of your fact table. But in this example, in this table, I am including the description values. At the same time, I'm including the measurable values also. For that reason, this table we cannot able to call it as a fact table. And one more thing, in the dimensional modeling, can we able to say, is it a proper table as per our definition? Is it a proper table? Simply we can able to say the dimensional modeling is not at all a proper table. This is a kind of a completely invalid modeling on top of our dimensional modeling. And in that dimensional modeling, we are going to maintain the dimensional table separately, and we are going to maintain the fact table separately. In the dimensional tables, we are going to maintain the dimensional values. In the fact table, we are going to maintain the fact values. Like that, we need to understand how we are going to maintain the dimensional modelings as part of our data warehousing projects. Okay. Any other questions up here?
So we are maintaining fact table for each and one fact table only. Like we are maintaining only one fact table for each and every dimension table, or number of fact tables.
No, you want to tell me. So your question is, for a fact table, are we going to maintain the single dimensional table? That is your question. You will tell me, for a single fact table, are we going to maintain the single dimensional table, or we are going to maintain the multiple dimensional tables also?
Multiple.
My answer is, we can able to see multiple dimensional tables, which can able to surrounded by the fact tables. So there is the possibility we can able to see the single dimensional table on top of the single fact table, but in the real time, most of the times we are going to see the multiple dimensional tables which are surrounded with the fact table, or multiple dimensional tables which are having relationship with our fact table. So coming to your question, I can able to say there are the chances, or in the real time we can able to see one fact table can able to have relationship with the multiple dimensional tables. Is it clear?
And also multiple fact tables also there.
Yeah, there is a possibility for multiple fact tables also, definitely.
Yeah, actually we are maintaining multiple
Yeah,
dimension
definitely.
tables.
So
So we
because
have
if you are going to work in the real-time projects, so don't think that we are going to see the only single fact table. We are going to see the multiple fact tables in our real-time projects. Okay. Now, for example, we are having the table called as the sales fact table. In this sales fact table, we are going to maintain all sales related measurements. Okay. And in the same way, we are going to maintain, for example, X_fact table. In this fact table, we are going to maintain all X related measurements. So like this, we can able to see the n number of fact tables as part of our real-time projects only. But what is the basic functionality of the fact table? In the fact table, we are going to maintain all the fact values, and every fact table is going to have the relationship with the multiple dimensional tables. Now you tell me, for example, we are having the fact table 1. This fact table 1 is having relationship with the dimensional table 1, and we are having the fact table 2, and this fact table is going to have the relationship with the same dimensional table 1. Is it possible or not? This is possible in real time, because in the real time I'm only saying that we are going to see the multiple fact tables only. First fact table is having relationship with the dimensional table 1. Second fact table also can able to have the relationship with the same dimensional table. Such kind of scenarios also we can able to see as part of our real time projects. Okay, don't think that we are going to have the single fact table in the real time projects only. In the real time we are going to see the n number of fact tables, but in every fact table we are going to maintain the measurable values, and every fact table is going to surrounded or is going to have the relationship with the multiple dimensional tables as part of our real time projects or as part of our dimensional modeling. Okay, any other questions today? Okay, if no questions, I will show you one example. With that, you can able to get the clear picture. Just observe here. Yeah, as I told you in the dimensional modeling. So first, initially we discussed about the generic example and one central table which is surrounded by the multiple tables. Now I am saying that instead of calling it as a normal table, what we are calling here, we are calling it as a fact table. This centralized fact table is surrounded with the multiple dimensional tables. Okay. Now in this example, just observe. We are going to have the sales fact table which is surrounded by the multiple dimensional tables. And if you observe, first one we are having the product name. In the product name table, we are having the product ID, product name, and we are having the branch name. In the location dimensional table, we are having the location ID, location name, and country name and state name. So like that, we are maintaining all the descriptive data in your location dimensional table. In the same way, we are having the one more table, for example, called as a time dimensional table. In this table, which columns we are having? Time ID column, year column, month column, day column. So like this, if you observe here, in this product dimensional table, what data we are maintaining? We are maintaining descriptive data for each and every product. Coming to location table, we are maintaining descriptive data for each and every location. In the same way, coming to time dimensional table, we are going to maintain descriptive data for each and every time period. For every time period, we are going to maintain what is the year, what is the month, what is the day. That's the reason all these surrounded tables, we are calling it as nothing but our dimensional table. Now, what is the centralized table we are having here? This centralized table, we are calling it as nothing but our fact table. Now, in this fact table, what's the measurable value we are having? We are having the measurable value called as a sales value only. Now, with the help of the fact table, you are going to maintain the relationship with our dimensional table. But you try to give the answer in database system. To maintain relationship between multiple tables, what we have to maintain or what we have to use? We need to use primary key and foreign key. With the help of the primary key and foreign key only, you are going to maintain the relationship between the multiple tables on top of our database systems only. Now you try to give the answer as part of dimensional modeling. Which table contains primary key and which table contains foreign key? Any guesses? Here I'm
Fact
saying
table.
that in the database system, to maintain the relationship between the multiple tables, we need to use the primary key and foreign key. Now in the dimensional modeling, you are having the centralized fact table, which is surrounded by the multiple dimensional tables. And in this scenario, which table is going to contain the primary key and which table is going to contain the foreign key?
Dimension tables contains the primary key and foreign keys are like fact tables.
Yes, correct. And so centralized table, which is nothing but our fact table, this is going to contain foreign keys. Because by using this table, I want to maintain the relationship with the other tables. For the reason, this fact table is going to contain the foreign keys. And now coming to here, whatever the surrounded tables we are having, those are nothing but our dimensional tables, and that we in the dimensional tables we can able to see the primary key. So in the centralized fact table, we are going to see all the foreign keys, and surrounded dimensional tables are going to contain the primary key. For the reason, if you observe here, in this table, product ID column is acting as a primary key. In this table, location ID column is acting as a primary key. In this table, time ID column is acting as a primary key. Now in this sales fact table, we are going to see other columns like this, and PID column, it is acting as a foreign key here. It is nothing but in between product dimensional table and fact table, with the help of the PID column, we are going to maintain the relationship. And in between location table and fact table, how we are going to maintain the relationship? By using our location ID column. In between time dimensional table and fact table, by using which column we are going to maintain the relationship? By using our time ID column, which is nothing but in the fact table, we are going to maintain the foreign keys. All the surrounded dimensional tables are going to contain the primary keys. And now with the help of this primary key and foreign key only, we are going to maintain the relationship between the fact tables and dimensional tables. Now you try to give the answer by using this statement. What is the fact table? By using this diagram, you try to give the answer. What is the fact table? Fact table is going to contain the fact values. But if you observe here, earlier I given the statement like this, and in the fact table, if we are going to maintain all the fact values, such kind of table we can able to call it as a fact table. But in this example, if you observe, we are maintaining only the fact values, or we are maintaining any other columns also in the fact table? In the fact table, are we going to maintain only the fact values, or we are going to maintain any other columns also in
Only
this
fact
table?
values.
Then what about this PID, LID, and TID?
Descriptive columns.
So we can able to say in the fact table, we are going to maintain fact values, and also we are going to maintain key columns information. So what we are doing here, in a table, if you are going to maintain all the fact values, and if you maintain key columns information, such kind of table we can able to call it as a fact table. Earlier, for your easy understanding, I mentioned that in the fact table we are going to maintain the fact values. Still, I am giving the same statement. In the fact table, we are going to maintain the fact values only. But other than these fact values, what else the data we are maintaining? We are maintaining the PID foreign key, location ID foreign key, and time ID foreign key. Indirectly, in the fact table, other than the fact values, we are going to maintain some kind of key columns, and these key columns only indirectly we can able to call it as nothing but dimensional key columns. What we are doing here, we are calling it as a dimensional key columns. If we are going to maintain the dimensional key columns on top of your fact table, on top of the table, such kind of table simply we can able to call it as a fact table. Now why we are calling it as a dimensional keys? Any guesses? Why we are calling PID column, LID column, and TID column as a dimensional keys? Because with the help of the PID column, I am maintaining relationship with the product dimensional table. With the help of the LID column or location ID column, I am going to maintain the relationship with the location dimensional table. In the same way, with the help of the time ID column, we are going to maintain the relationship with our time dimensional table. Indirectly, by using all these three columns, we are going to maintain the relationship with our dimensional table. Actually, we can able to call it as a foreign keys, and but in the dimensional modeling, instead of calling it as a foreign keys, what we are calling here, we are calling it as nothing but dimensional keys. Now you try to give the answer. In which table we are going to maintain the dimensional keys? In the dimensional modeling, in which table we are going to maintain the dimensional keys? In the fact table. And you try to give the answer. What is the definition of dimensional key? Any guesses? By using all our discussion, we can able to say to maintain relationship between fact and dimensional tables. we are going to maintain few key columns in.
But we also call it as foreign key, right?
Yeah, you can call it as a foreign key. In the general database terminology, you can able to call it as a foreign key only. But when we are discussing about the dimensional modeling, in the dimensional modeling, instead of calling it as a foreign key, we are given the naming convention called as a dimensional key. That's the reason. See, dimensional key is nothing but foreign key. But in the dimensional modeling, instead of calling it as a foreign key, just we are going to use a terminology called as a dimensional key. That's the reason I'm saying that to maintain relationship between the fact table and dimensional tables, we are going to maintain few key columns, or we can able to call foreign key columns in fact table, and those columns only we can able to call it as dimensional keys. This is the way simply you can able to understand what is the meaning of dimensional key. Now, if you observe here, is it a simple statement or a complex statement? It's a big statement, but don't feel that it's a kind of a complex statement only. Try to understand one by one. First, what we discussed in the fact table, we are maintaining all the fact values. With that, we started the discussion. In the fact table, we are going to maintain all the fact values. But in the dimensional modeling, we are going to have the centralized fact table, which is surrounded with the multiple dimensional table. By using the fact table, we need to maintain the relationship with all the surrounded dimensional tables only. But if you want to maintain the relationship, what we need to do here, we have to maintain the foreign keys in the fact table. But instead of calling it as a foreign key, what we are calling here, we are calling it as a dimensional keys only. With that, I am given the fully definition of your fact table here. In a table, if we are going to maintain all the fact values and if we are going to maintain the dimensional key column information, such kind of tables we can able to call it as a fact table. This is the complete definition of your fact table. And again, I'm repeating, by seeing the statement, don't be scared and don't be get any kind of confusion. It's very easy thing. If a table is having all the fact values, which we are calling it as a fact table, other than fact values in the fact table, to maintain the relationship, we are going to maintain the key columns. Those key columns only we are calling it as a dimensional keys, which is nothing but fact table is nothing but is the combination of fact values and dimensional keys only. Such kind of tables we are calling it as nothing but our fact table. This is the way you need to understand what is the fact table and what is the dimensional tables. Okay. Any questions again up here? Please ask me.
Sir, our dimensional table, we are maintaining only descriptive columns, right?
Yes, correct.
So, for, which means we should not maintain any aggregation columns.
Yeah, we are not going to maintain any aggregation columns in the dimensional table. Indirectly, you tell me where we are going to maintain the aggregate columns.
Fact tables.
In the fact table. So, for example, here if I'm given the sales only, is nothing but we are going to maintain the total sales information on top of your fact table, which is nothing but it is going to contain the measurable values, or we can able to call it as a aggregate values. If you remember the yesterday's example, in the Citibank example, business people are going to perform analysis on top of the turnover. Now you tell me, we are given the total turnover or we are given the individual transaction information? We are giving total turnover. What is the meaning of total? Is nothing but sum operation. What is the meaning of summing? Is nothing but our aggregate data. Indirectly, on top of the fact table, we are going to maintain the measurable values. Those measurable values are nothing but our aggregate data only.
And
Okay.
also in dimension table, whatever we are taking a primary keys, those comes foreign keys in fact table.
Yes, correct. Whatever the primary keys are acting in the dimensional table, those keys are going to act as a foreign keys on top of your fact table. Okay. Any other questions up to here? Okay. If no questions, I will ask few questions and try to give the answer. What is the in-one approach? So by listening all these things, hope you forgot about all the previous topics.
Bottom-up approach.
What is the in-one approach? Simply we can able to call it as a bottom-up approach. In which architecture we are having the in-one approach? In the federated data warehousing architecture. Okay. Because of discussing some new topic, don't forget about the previous topics, because every topic is interlinked here and every topic is important here. So we discuss about the centralized data warehousing architecture. We discuss about the federated data warehousing architecture. Now you tell me, what is the difference between the centralized data warehousing architecture and federated data warehousing architecture? Difference between
Data marts we have in the federated
centralized
architecture
and federated. Yes, we can able to say we are having one extra layer in federated, that only we are calling it as nothing but data marts. Okay. Now next one, in data warehousing projects, what kind of modeling we are following?
Dimensional modeling.
You are modeling and dimensional modeling. Is the correct answer? We are following the both ER modeling and dimensional modeling, or we are following only dimensional modeling?
Only dimensional modeling.
Only dimensional modeling. Okay, don't think that because of discussing on the ER modeling in the class, we are following the ER modeling in the data warehouse. That's a kind of a wrong statement. Only for understanding, we discuss about what is the ER modeling. But as part of data warehousing projects, what we are doing here, we are going to follow the dimensional modeling. Okay, now you tell me, in the dimensional modeling, what kind of tables we can able to see?
Fact and dimension tables.
We can able to see the fact and dimensional tables. Okay, and what is the meaning of fact?
Measurable values.
It's a kind of a measurable value. And what is the meaning of dimension? It's nothing but we can able to call it as a descriptive data, or we can able to call to define fact values. We are going to use dimensional values. Okay, and what is the fact table? Fact table contains all the fact values. That's it.
Dimensional key
Also
columns
key
also.
values
If they are the dimensional keys.
Dimensional key.
At the beginning, you don't know about the dimensional keys. For that reason, I haven't included that. But now you know end to end of the dimensional modeling. So with that understanding, you have to say fact tables are going to contain the fact values, and also it is going to contain the dimensional keys. Okay. In the same way, what is the dimensional table? Contain all dimension values, or we can able to say it is going to contain all the descriptive values. Okay. One last question here. What is the dimensional key? What is the dimensional key?
Foreign.
By using this key, don't give the answer as a foreign key. And by using this key, we are going to maintain relation between fact and dimension tables. And which tables are going to contain the dimensional keys? Fact tables will contain dimensional keys. Okay, all these are the some basic statements you have to understand based on the previous topic only. So before 5 minutes, whatever we discussed, by using that, you need to understand all this kind of information, because again, I'm telling you the same thing, just I'm repeating the one more time. Why we are discussing all these things? In the requirement documents, we are going to see all these kind of statements. What statements we are going to see? So this table is a fact table. This table is a dimensional table. We are following the dimensional modeling in this project. Whenever
Yes. Sir, I am not able to hear you.
So your voice is not audible.
Sir, your voice is not audible.
Maybe network issue. Servers disconnecting.
am I audible?
Yes, sir.
Yes, sir.
Yeah, here power because of transformer blast power cut here only. So I connected through the mobile data. Yeah, we can continue. Hope you are able to see my screen also.
Yes, sir.
Okay. Yeah. So why we are discussing all these things? So because projects in the requirement document, we are going to see all these kind of terminologies only. For that reason, we are trying to understand all this information. At the same time, as part of interviews also, they will ask these kind of questions. What is the dimensional modeling? What is the fact table? What's the dimensional table? And what is the N1 approach? What is the data mart? So as part of interviews, it is important. At the same time, if you are going to work in the real-time projects also, we are going to see all these kind of terminologies. For that reason, we are trying to understand all these things. At the same time, I know all these are theoretical topics. Definitely will get some kind of bore feeling, but we don't have any other option. We cannot able to skip these topics, and for that reason, please have some kind of patience and try to understand all these three topics. And mostly by tomorrow, we can able to complete the data warehousing concepts. Tomorrow also is a kind of a theory session only. Try to understand only for data warehousing concepts is a kind of a complete theory. You cannot able to perform any practicals on top of the data warehousing concepts. All these are the terminologies we need to understand. Once you understand the terminologies, as part of use cases, we can able to implement all these kind of terminologies. Okay. So don't be feel as a bore feeling or anything on this. So try to understand everything. With that, you can able to get the end-to-end knowledge. Okay. So that's all from my
Sir-
side. Before winding
sir,
up,
I
any
have-
questions, please ask me. Yeah, please.
In the ER, where we use the ER model, sir? Actually.
You are going, so actually, if you are going to maintain some kind of web application projects, or if you are going to handle the mobile application projects, there also we are going to maintain the databases, and in such kind of projects, we are going to see the ER modeling.
Okay, sir.
Okay,
Sir,
if you are
I
going to
have
work in
one-
the data warehousing projects, in the data warehousing projects, we are not going to see the ER modeling. Yeah, please continue.
Sir, one more question I have.
Hmm.
Suppose OLTP, we are pulling data from OLTP to our data warehouse or OLAP.
Mhm.
In the OLTP, we have all those things like fact tables and the relationship between the dimension tables.
No, in the OLTP, we won't have any kind of fact tables and dimensional tables. And if you observe here, where if you see the architecture, where we are going to see all the fact tables and dimensional tables, in the data warehousing system, which is nothing but in the data warehouse component, we are going to see all the fact tables and dimensional tables. ODS is nothing but OLTP. In the ODS, what we are going to maintain, we are not going to maintain any fact tables and dimensional tables. In the data warehouse component, we are going to maintain our fact tables and dimensional tables. So with that, please continue with your question.
Yeah, that means we are not maintaining any relationship between the tables in the OLTP, sir.
No, in the OLTP, you are going to maintain the relationship if you are going to have the tables, but there what kind of modeling we are following? There we are following the ER modeling in the ODS. And one more thing, tell me, as we discussed yesterday, do we have any control on the ODS? As a data engineer or as a part of data warehousing, it is completely under the control of the source team. That source can be web application, that source can be mobile application. As I told you earlier, for example, source is the web application. If that is the web application project, obviously what they will do here, they are going to maintain the database system. In that database, might be they are following the ER modeling, but once we are pulling all the data into our data warehouse component, here we are not going to maintain the ER modeling. Here completely we are going to maintain the dimensional modeling.
Okay, that means suppose how we are suppose the tables are structure schema we are maintaining or loading that from the OLTP to OLAP or data warehouse. The table structure should be suppose they are maintaining foreign key, primary key. We have to remove and load or how we are loading the data table structure.
You tell me if you want to load the data, do we need to remove on the OLTP side? It's not required, right? So just we are reading the data. We are not doing any operations on the ODS. Just we are going to read the data. After reading the data, we are loading the data into your staging database. And in the staging database, we are not going to maintain any kind of relationships. But coming to data warehouse system, by depending on our requirement, either we can able to create the primary keys and foreign keys again by depending on our requirement. Indirectly, I'm trying to say whatever the relationships we are maintaining in the ODS, we are not going to replicate the same relationships on our data warehouse system. If we are going to maintain the same relationship, then what is going to happen? Here also indirectly, we are going to maintain the ER modeling only. That's the reason I'm saying that whatever the relationships we are having, for example, in the ODS or OLTP, we are not going to replicate the same information on top of our data warehouse system. Here, as per the requirements, we are going to divide the descriptive data. We are going to divide the summary data. That data we are loading into the individual dimensional tables and individual fact tables, and all those operations we are going to perform from ODS to our data warehouse. That only we are calling it as nothing but our transformation. It's not a straight down. It's a kind of we are applying the transformations. By applying the transformations, we are dividing the descriptive columns and we are deriving the measurable columns. Descriptive columns we are loading into the dimensional tables, and measurable columns we are loading into the fact tables.
Yes, it's clear, sir. Thank you.
Okay, thank you. Any other questions?
Sir, one more question, sir.
Yeah, please.
Regarding data mart. Sir, who will create the data mart data sets?
We only. See, in this whole architecture, who is creating staging database?
Yes, sir.
It's your responsibility. Who is loading the data into staging database? Your responsibility. Data warehouse is nothing but a database. So don't get the confusion on it. Staging database, data warehouse, views, where all these three will present. All these three will present in your database system only. Only for understanding, we are segregating it as a staging database and data warehouse and views. Okay. Now, if everything is present in the database system, who is going to create all these tables and databases? As a data engineer, you are going to create the tables, and who is going to load the data? As a data engineer, you are going to load the data. In the same way, if you are introducing a new layer called as a data marts only, where we are going to have the data marts as we discussed earlier. Data marts are nothing but it's a kind of a subset of data warehouse, or we can able to say here we are going to maintain the individual department data into the individual database only. Again, data marts are nothing but database only. Who need to create the database? It's as a data engineer our responsibility, or our DBS will create the databases or data mart. On top of that, we need to create the table and we need to load the data. Indirectly, I can able to say in this whole architecture, as a data engineer, where you are going to perform your activities. You try to give the answer. Yesterday we discussed about that. In this whole architecture, as a data engineer, where you are going to perform your activities.
Staging DB2
Staging, data engineer responsibility. Data warehouse, data engineer responsibility. Data marts, data engineer responsibility. Views, data engineer responsibility. Indirectly, in all these 4 stages or all these 4 areas, and as a data engineer, you are going to work in our real-time projects. Is it clear?
Yes.
Okay. Any other questions still?
So this information about foreign key and primary key, this information do we get in the requirements document? Which column is primary and which column is foreign?
We'll get that information in the requirement document clearly, which is the primary key and which is the foreign key. Otherwise, you cannot even understand what is the relationship or what is the dimensional key column, right? That's the reason they will give all the kind of information as part of our requirement documents or as part of our PDF document. PDF is nothing but physical data model document. Either in any one of the document, they will share all this kind of information.
Thank you, sir.
Okay. Any other questions? Okay, if no questions, that's all for nowadays. So we'll connect in the 11:45 session. But here I can able to say power outage is here. For now, I connected with the mobile data. So if power is back, we'll have the session only. I will give the update once power is back by 10:30 or 10:45. I will give the update to you. If power is back, then we'll connect at the 11:45. Okay.
Okay, sir. Happy Teachers Day, sir.
Yeah, thank you.
Happy days.
Happy
Teachers Day, sir. Thank you.
Happy
Okay,
teachers.
thank you.
Thank you. Teachers Day.
Thank you all. Thank you. Okay, have a nice day. We'll connect at 11:45 if power is back. Thank you.